Good evening. Good evening.
Very good evening, sir. Atul sir, very good evening.
Good evening. Good evening.
Am I audible to all participants? Please mention in chat box. Thank you, Dr. Rashid. Thank you, Dr. Sandeep. So, with the permission of our chairperson, Dr. Atul sir, may I start the session?
Please, sir. Please go ahead. Go ahead.
Thank you, sir. Thank you. A warm welcome and very good evening to all dear participants. Resource person of today's session, Dr. Anup Kumar sir, and chairperson of today's session, Dr. Atul Juneja sir. Today, we are having our lecture on testing of difference parametric tests. Now, I would like to introduce today's resource person of the session, Dr. Anup Kumar sir. Dr. Anup Kumar sir is currently working as an associate professor at Department of Biostatistics and Health Informatics, Sanjay Gandhi Postgraduate Institute of Medical Sciences, Lucknow, Uttar Pradesh. Dr. Anup Kumar sir is having more than 10 years of teaching experience. In past, sir worked as assistant professor at RGSC Banaras Hindu University, Barkacha for period of 3rd October 2012 to 23rd March 2013, and at Department of Statistics, School of Mathematics, Statistics and Computational Science, Central University of Rajasthan for period of 1st April to 26 July 2013. Sir also worked as assistant professor at Department of Statistics, University of Allahabad. And Dr. Anup Kumar sir has received various awards from 3rd to 5th November 2003. Sir presented a poster entitled Sampling Frame as Determinant of Mean of First Birth Interval in 31st Annual Conference of IASP held at SV University, Tirupati. The poster was conferred with Professor S.N. Singh Award. During 11th to 13th November 2011, Sir presented a paper entitled Sex Ratio at Birth, a Model-Based Approach in 33 Annual Conference of IASP held at SGPG Institute of Medical Sciences, Lucknow. This paper has been conferred with Dr. C. Chandrasekharan Young Scientist Award. Sir has organized workshops on understanding statistics through MS Excel and SPSS held at Department of Statistics, Faculty of Science, University of Allahabad. A workshop on biostatistical computing with R held at Department of Biostatistics and Health Informatics, SGPGIMS, Lucknow. And also organizing a national workshop on statistical thinking and data analysis held at Department of Statistics, Faculty of Science, University of Allahabad. Dr. Anup sir is invited as a resource person for workshop on LaTeX and other open source software held from 25th to 27th March 2010, organized by DST CMS, Banasthali University. Sir invited and delivered lectures during various national and international workshops at organizations like DST CMS, Banasthali University, Regional Training Institute, Allahabad, Institute of Management Studies, BHU, Center of Food Technology, University of Allahabad, Department of Mathematics and Statistics, Sakuntala Mishra National Rehabilitation University, Lucknow, Department of Biostatistics, Himalayan Institute of Medical Sciences, Swami Rama Himalayan University, Dehradun, and MIT University, Uttar Pradesh, Lucknow, and the CMC Ludhiana, Punjab, Dr. Ram Manohar Lohia Institute of Medical Sciences, Lucknow, and Raja Motia Dental College and Hospital, Annamalai University, and many more. Sir has published more than 15 papers in various national and international journals. Sir has participated and presented paper in more than 28 workshops, seminars, and conferences. Now, I would like to request sir to kindly lead today's session. Please, sir, welcome, sir.
Thank you, Amit. I'm actually struggling with this WebEx.
No problem, sir. If there is any technical difficulty, then let me know. I will
I'm solving this. So I think the slide is visible.
Yes, sir. Fine.
Yes,
sir.
yes.
Good evening, Atul sir. Nice to see you.
Good evening. Good evening. Nice to see you.
So today I will be talking on this topic of introduction to testing of hypothesis. And then today just my focus will be only on the parametric approach of testing a hypothesis, and I think a day after tomorrow, I will be talking on the non-parametric approach on testing of hypothesis. So, so this is what I have planned that I will cover today. And first of all, I will try to introduce you people about uh, testing of hypothesis. Then I will be talking about jet test, t-test, also for test concerning for population proportion. Then testing equality of mean means for two independent sample, and also for the paired sample case. And finally, I will talk about the testing equality of the two population proportion. So all these topics I have planned to cover in the today's session. Various statistical software, I don't know what is the target of this particular workshop, but whatever software you will use, all the uh, ways of doing the parametric test, lots of YouTube videos and lectures are available online. But the essence of making a statistical hypothesis and uh, interpreting the result which you obtained after doing a statistical analysis through a software is very, very much important, and I will try to let you know that how you people can interpret the result once you analyze your data or once you do any kind of testing of parametric testing of hypothesis. So first of all, let me give you a sense of that what is an statistical hypothesis. So first of all, I will explain what a statistical hypothesis is and show how a sample data can be used to test it. Then very important portion, how to set up a hypothesis, and simultaneously how to distinguish between a null hypothesis and alternative hypothesis. Then I will try to explain the level of significance or significance of rejecting a null hypothesis and not rejecting a null hypothesis. We'll also try to explain what are the two kinds of error that you can commit while accepting or while rejecting or do not rejecting a null hypothesis. A very famous term, p-value. So I will also try to explain the concept of p-value. And finally, I will discuss different type of parametric hypothesis test concerning to one or two population or groups. So let me start with this example. And this example basically is just a statement. Most of your research question also start with a statement. So you can think of this example as a statement that there has been a great deal of controversy in recent years over the possible danger of living near a high level of electromagnetic field, means high level of wires which are crossing over some household areas. So one researcher, after hearing uh, many tales concerning the large increase in cancer, especially among children in the communities who are living near an EMF, decided to study the possible danger. Okay, so he want to study whether the kids who are living near a EMF area, whether all those kids have higher chance of developing cancer or not. So this is basically the research question. He want to test it. Now, how he will proceed He will proceed in this way that she first studies all the location uh, or the localities which are lying near the electric power lines, and then use them to select a fairly large community that was located in the level EMF area. Okay, and then she uh, started questioning or moving or interviewing all the peoples who are living in those area, also to the schools, hospital, and public health facilities in order to discover the number of children who have been affected with any kind of cancer in the previous 3 years. And she found that there has been 32 such cases. So this is what she have found, that in last 3 years, 32 cases she identified. Now the question is that whether this number indicates his hypothesis that whether living near a EMF area is going to increase or decrease. So for that, she have to uh, know what is the baseline. Means if the person, what is the person, whether he is living the near a EMF area or not living near the EMF area. What is the general incidence of childhood cancer? So for that, she visited a government public health library, and she learned about the number of cases of childhood cancer that could be expected in a community, the size of the one which she was concerning, and she learned that average number of children of childhood cancer over a 3-year period in such community was 16.2, with a standard deviation of 4.7. Now, in her area, she noted it as 32, and here in general it is 16. Now, the question is the discovery of 32 cases of childhood cancer significantly large enough in comparison with the average number of 16.2 for the researcher to conclude that there is some special factor of the community being studied that increases the child of childhood cancer in such area, or it is just a random chance that she got such data. So this is what basically the particular question is. Okay. So you can take this particular example also. Another example that we all know that advances in ultrasound examination for prenatal checkup, it also makes them possible to determine the sex of the child in early age of the pregnancy. So there is a fear that in some culture, some parents may use this technology to for the sex selective abortion. A study in 1994 from Punjab, India reports that in one hospital, around 56.9% of 550 live birth in a particular year were boys. So it's a medical fact that the male babies are slightly more common than the female babies. So it was around 51%, but here they are getting 56.9%. So the study authors reports a baseline for this region of 51.7. So whether this difference 51.7 to 56.9, so whether this indicates that whether in that particular area there is a sex selective abortion or not. So is this is the evidence that the proportion of male birth is different in this hospital? Uh, Also, you can take this example. Just a minute. हाँ बॉस. हेलो. हाँ बॉस, बताए बॉस. स्टूडेंट का बॉस, उसकी थीसिस का है. हाँ 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 बॉस, हाँ हाँ, ये मतलब डेटा. नहीं 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 बॉस, नहीं. हम्म 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 Okay. ओके बॉस, ओके बॉस। दे देंगे बॉस, कल कर देंगे, कल कर देंगे। हम्म। हम्म। कर देंगे बॉस, थैंक यू, कर लेंगे बॉस। जी जी जी। नहीं 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 नहीं। समझ गए बॉस, समझ गए, कर लेंगे, थैंक यू सो मच, थैंक यू। So similarly, this is another query, or you can say statement, that an RTO officer claimed that 80% of the candidate passed driving test, but a newspaper report survey says that 90 randomly selected local teens who have taken the test found only 61 have of them as passed. So now the question is, does this finding suggest that the passing rate for teenager is lower than the RTO reported? So similarly, people wants to answer such question. Has teenager smoking decreased in the past 5 year? Is the global temperature is increasing? Did the Cadbury ad "Kut Meetha Ho Jaye" actually increases the sale? And to answer such question, we have to prepare a statistical hypothesis and test them. Now, what is a statistical hypothesis? So it is a statement about the nature of population or the phenomena under study, we can say, and it is often stated in terms of population parameters. So this definition basically is what uh, quite precise, but its meaning is very generalized. What is this nature of population is something that we can say that uh, if somebody claims that a woman whose income level is low, okay, so the children born to women whose income level is low, their weighted birth of their babies are low, are usually very less than. So this is what a statement, this is what means a woman who belongs to a lower income group, lower income group. Now, if a baby is born to that particular woman, his weight, it will be less than say 2.5 kg. So this is what a statistical hypothesis is. It is a statement about nature of population. Okay. Now, and it is often stated in terms of population parameter. So here the population parameter is mean mu. Mu is the population parameter. So this statement about the population is often stated in terms of mean mu. In generally, it is stated in terms of mean mu or in terms of proportion P. So, to test a statistical hypothesis, we must decide whether that hypothesis appears to be consistent with the data of the sample or not. Now, the next, why it is called statistical hypothesis? Because we need a data to prove or disprove a hypothesis. So, otherwise, it is generally a hypothesis. So it is not necessary that every time to prove a hypothesis you require a data. But whenever you have to prove a hypothesis statistically, or a hypothesis termed as statistical hypothesis, when we require data to prove it. Okay. Now take this example and we'll become more precise. So suppose that tobacco firm claims that uh, now it is a tobacco firm. Okay, they are a company, and that tobacco firm claims that they are preparing uh, a tobacco leaf, and in such tobacco leaf, the mean nicotine content in the cigarette, it will be 1.5 milligram or less. This is what their claim is, that they are preparing a cigarette and the mean nicotine content in a cigarette is 1.5 milligram or less. Now, a researcher is uh, skeptical about the claim of the company, and he believes that the mean will exceeds 1.5 milligram. Okay, now this is very important. He believes the mean is going to exceed 1.5 milligram. So to disprove the claim of the tobacco firm, the researcher had decided to test its hypothesis that the mean is less than or equal to 1.5 milligram. Okay, so here to start hypothesis to be tested, first of all, it is termed as the null hypothesis, and it is denoted by, in statistical theory books, H naught, or you can also denote it by simply, since it is a null, so Hn. So, but it is usually denoted by H naught, and here the null hypothesis is what which the company is claiming. Company is claiming that the mean nicotine content in a cigarette is less than or equal to 1.5 milligrams. Okay. And what is the alternative hypothesis? It is generally denoted by H1 or sometimes HA. And since our null hypothesis is this, and the researcher wants to reject this hypothesis. Okay, so what is our alternative hypothesis? Our alternative hypothesis will be this. H1, mean nicotine content of the cigarette, is more than 1.5 milligram. Okay. So with this thing, now what he have to do? So now the hypothesis is set, and he have to test this null hypothesis. Logic is very simple. He have to take a sample, random sample of the cigarette which are prepared for that company, and measure the nicotine content in that sample. And if the resulting data are not consistent with the null hypothesis, then we say that the null hypothesis is rejected. And if they are consistent with the null hypothesis, then the null hypothesis is not rejected. We are not talking about accepting anything. Either we'll reject the null hypothesis or we fail to reject the null hypothesis. So with this idea in the mind, how we are going to make the decision on the basis of the data? So the decision of whether to reject the null hypothesis is based on a value, and that value is termed as test statistic. Okay. So test statistics is a statistical value which is determined from the sample, the data which we have collected, and depending on the value of this test statistics, we make a decision to reject the null hypothesis or not. Okay. Now, in this example, we all know that the statistical test would be reject the null hypothesis if it is sufficiently larger than 1.5 milligram. Now the question is that how much it should be large. Okay. So for that, we are going to prepare a region which is termed as a critical region, or also termed as rejection region, and it is the set of values of the test statistics for which the null hypothesis is rejected. So mathematically, if it has been rejected, so we can write down that reject H naught if the test statistics is going to lie in this critical region, and do not reject the null hypothesis if the test statistics is not going to lie in this critical region. So how we are going to prepare the critical region? So if uh, somebody is going to say that mm, uh, if it is known that the standard deviation I think that you people have the concept of standard deviation, the classes on uh, mean, standard deviation, all these things being already covered in this workshop. So if the standard deviation of the nicotine content is 0.8 milligram, then this is the formula for preparing the critical region. Means if the values is more than 1.5 plus 1.312 divided by under root n. Okay. So we are going to reject H naught if the value of sample mean is more than this value. Otherwise, we are going to reject this, where n is the sample size. So if we consider that we have randomly selected 36 nicotine, so for this 36, if the mean is more than 1.719, so we are going to reject the null hypothesis, and if the mean is less than 1.719, so we do not reject the null hypothesis. So note that even when the estimate of mean mu x bar it is more than 1.5, the null hypothesis may still not be rejected. When indeed when n is equal to 36, a sample mean value of 1.7 will not result in rejection of the null hypothesis. This is true even though such a large value of sample mean is certainly not evidence in support of the null hypothesis. Okay. So nevertheless, it is consistent with the null hypothesis in that if the population mean is 1.5, then there is a reasonable probability that the average of the sample of size 36 will be as large as 1.7. On the other hand, the value of the sample mean is as large as 1.9 is so unlikely if the population mean is less than or equal to 1.5 that it will lead to the rejection of the null hypothesis. So by this particular formula, they have created critical regions at all those values which are more than 1.719. Means you take a random sample, calculate the mean. If the mean is more than 1.719, so you have to reject the null hypothesis. That is what in such a way they have created this critical region. So finally, what is the interpretation? The rejection of the null hypothesis H naught is a strong statement. Then we can say that what we should usually say that H naught means the null hypothesis does not appear to be consistent with the observed data. So usually in many research article, I see that the null hypothesis is rejected. So, but we should usually say that this null hypothesis is not consistent with the observed data, or the vice versa. If instead of saying that H naught is not rejected is a weak statement, and we should say that as H naught is consistent with the data. So try to interpret your result in this case. Now, while making this decision, what actually we are doing? We are trying to divide the hypothesis uh, or we are going to make a decision whether our hypothesis, null hypothesis, is rejected or it is not rejected. So while doing this on the basis of decision, we are going to commit two kind of an error. The first kind of error is termed as type 1 error. It is something that if our test statistics reject the null hypothesis when in reality our null hypothesis is true. And the type 2 error, that if the test does not reject the null hypothesis when the null hypothesis is false. So these two kind of error we can commit whenever we are testing a hypothesis. Type 1 error, reject H0 when H0 is true, and the type 2 error, do not reject H0 when H0 is false. Because of the data which is in our hand, we may commit these two kinds of error. Now, what is the objective of a statistical test? So, the objective is now, it must be understood that the objective of a statistical test, this statistical test of the null hypothesis S naught is not to determine whether S naught is true, but rather to determine if its truth is consistent with the data. Therefore, given this objective, it is reasonable that H naught should be rejected only if the sample data are very unlikely when H naught is true. So now we'll move to the level of significance alpha. So the classical way of accomplishing this is to specify a very small value of alpha and then require that the test have this property, that probability of type 1 error should be less than or equal to alpha. This is also termed as level of significance, and usually it have the value which is being denoted by 0.10, 10%, 5% or 1%. In advance, before starting the hypothesis, we simply give the values of level of significance. Now, this is very much important designation of the hypothesis. Now, if you are trying to establish a certain hypothesis, then that hypothesis should be designated as the alternative hypothesis. You can also remember that particular fellow wants to reject the hypothesis or the claim which is being made by the company that the mean nicotine content is less than or equal to 1.5. So he want to disprove this statement. That's why the null hypothesis is mu is less than or equal to 1.5 milligram. What he wants to actually prove, he wants to prove that mean is more than 1.5 milligram. So what you want to prove, okay, that actually becomes your alternative hypothesis. That is the way to decide your null hypothesis, or whatever your research question is, actually that should become your alternative hypothesis. So for example, if the same problem, if the tobacco company is running the experiment, if the tobacco company is actually running the experiment and he have hired some researcher to prove his statement. So in that case, you can see the alternative hypothesis is mu is less than 1.5, because now he wants to prove this. Okay, whatever the data is, that is a different aspect, whatever the data is, but in such case, the alternative is hypothesis something which the researcher wants to prove. Okay, and the null hypothesis is just the reverse of the alternative hypothesis. Then the company could use a rejection of the null hypothesis as a proof of its claim that the mean nicotine content was less than 1.5 milligram. So this is very important for all of you to understand. So how to start? I think first of all, convert your research question into the hypothesis. So whatever you want to prove should be come into your alternative hypothesis, and whatever is not lying into the alternative hypothesis should go into the null hypothesis, where this mean is going to lie in this region R, or mean is lie in this region R, where theta is the parameter of interest. It can be mean or proportion. Then fix your level of significance, alpha. Uh, Usually its value is 5%, 1%, 10%, and it's actually depends upon the severity of making a error. If you people are going to make the error, and that error is going to have a life and death implication on the patient, then obviously try to decrease the level of alpha as small as possible. But if it is not such a case, then you can take the value of alpha up to 10% also. Then determine the parameter which are included in your hypothesis. Then determine the sampling distribution of that estimator, and find out the formula for critical regions. So all these things are actually mathematically done for you, and things are available in the software. So now just move to this two-sided t-test. Now, what is two-sided t-test? I'm saying why two-sided t-test. So suppose when our hypothesis is just going to depend upon the mean mu. Suppose we are about to observe the result of a sample size n from a normal population having an unknown mean mu and unknown standard deviation sigma, and suppose that we are interested in using the data to test the null hypothesis this, and our alternative hypothesis is that mu is not equal to mu naught. Okay, so what does actually it means if I'm saying that the mean birth weight of the baby is 3 kg? Okay, null hypothesis. An alternative hypothesis is that mean birth weight of the baby is not equal to 3 kg. So what does it mean? If null hypothesis is rejected, so it means that mean birth weight of the baby is either less than 3 kg or more than 3 kg. It means if inequality sign is there, so you can go both sides. That's why I'm saying that it is a two-sided t-test. Okay, so when you are using a two-sided t-test and the sigma is not known, so from the sample itself you calculate the sample standard deviation, which is denoted by this small s, and use this formula of test statistics. Okay, you can see that it actually measures the distance between the two mean, one mean which is under the null hypothesis and one mean which is calculated from the sample. So this is the distance between these two mean, and it is standardized by sample size and standard deviation. So if this statistics is very large, then we are going to reject the null hypothesis. Okay, so what they are saying that if this test statistics t is more than this tabulated value, then we are going to reject the null hypothesis. Otherwise, we are not going to reject the null hypothesis. And the p-value is also calculated by this formula, which is directly they will give into the output of the data. Now take this example to understand the. So this has been a claim that the level mean acidity pH level of rain in the certain industrial region is 5.2 pH. Okay, this is the historical data that the average uh, acidity level of rain is 5.2. Now, to see whether there has been any recent change in this value, the acidity level of 12 rainstorm over the past year has been measured, and with the following result. So these are the results. You can see now, are these data is strong enough at 5% level of significance. So this alpha is 0.05 for the researcher to conclude that the acidity of rain has changed from its historical value. So for this, they have calculated the sample mean, and it comes out to be 5.667, and the sample standard deviations comes out to be 0.921. Substituting these two value in the formula of this T, it comes out to be 1.76. Okay, and the tabulated value is 2.20. So you can see that the null hypothesis is not rejected at 5% level of significance. That is, the data are not strong enough to enable us to conclude that at 5% level of significance that the acidity of the rain has changed. And the p-value thus calculated is 0.107, that is more than 0.05. So this is also the indicator that we are failed to reject the null hypothesis, and so the null hypothesis would not rejected even at 10% level of significance. Now, what is one-sided t-test? So, as I told you that the previous example was about the two-sided t-test, because in that hypothesis, they are just testing whether mean is equal to 5 point, here you can see. They are just testing null hypothesis that mu is equal to 5.2 against the alternative that mean is not equal to 5.2. That's it. So that is what they are testing this hypothesis at two-sided. But whenever our side alternative hypothesis is like this, okay, so in such cases we are going to say that our hypothesis is one-sided, and we reject H naught whenever this same test statistics it is more than or equal to alpha. You can see now in the previous example here you can see it was alpha by 2 here because it is a two-sided, but now it is in one-sided, it will just take the value of alpha. Okay, and similarly the p-value is also, the formula of p-value also changes. This particular thing is usually not actually taken care by SPSS. In SPSS, all the results which they actually give on the basis of all their hypotheses are two-sided. So that is what you people should be very much cautious of while interpreting the p-value. So similarly, if your alternative hypothesis is of this kind, then also the test statistics value is going to be. So take now what is, if not only we are going to test for the mean, we can also going to test for the proportion, where proportion is anything about the population. We can say proportion of a smoker in an institute. So somebody want to estimate this proportion, or somebody is claiming that the proportion of a smoker is less than 30%. Okay, or he wants to prove that proportion of a smoker is more than 30% in an institute. So if such claims he wants to, if the statement is on this proportion, Then how to test this statement. Now instead of mean, we are using proportion over here. Okay, so what how to start with? So we take again similarly we take a random sample of size n, and in this n we'll observe that how many of them have a particular characteristic. Okay, so x, the number of member of the sample with a particular characteristics. Okay, so this x by n is actually give you the proportion. Okay, so take this example. Um Noted educator claim that over half the adult of Indian population is concerned about the lack of educational program shown on the television. To gather data about this issue, the NSSO randomly choose and question 920 individuals, and 52% means 478 of those surveyed stated that they are concerned at the lack of educational program on the television. Does this disprove the claim of the educator? Now, what a noted educator actually claimed that over the half of the adult Indian population is concerned about the lack of so 50% null hypothesis H naught, that this P is equal to 0.50, and this alternative hypothesis which is 52%. So whether this is actually, so now you can see that this null hypothesis P is less than or equal to 50%. Alternative hypothesis that this P is more than or equal to 50%. So they have just used this formula of using the binomial distribution. They find out that this P value is 0.1234 with this n is equal to 920 and P is equal to 50. So with this statement, for such a large p-value, we cannot reject the null hypothesis, and therefore cannot conclude that the educator's claims has been proved. Here also the criteria of one-sided p-test is also being calculated. So definitely the formula of calculation of p-value is also going to change according to that. So this is another example that historical data indicate that 4% of the components produced at a certain manufacturing unit are defective. So this is what historical data is saying, that 4% of the company produced at a certain manufacturing unit are defective. A particularly acrimonious labor dispute has recently been concluded, and management is curious about whether it will result in any change in this figure of 4%. If a random sample of 500 unit indicated 16 defective, that is 3.2%, is this significance evidence at 5% level of significance to conclude a change has occurred? Now again here this P is equal to 0.004 against the alternative P is not equal to 0.04, where P is the probability that an item is defective, and the P value is calculated based on this particular formula using this distribution, and the P value comes out to be 0.430, so which is extremely large. So there is no sufficient evidence to reject the null hypothesis. And what is the null hypothesis? That this P is equal to 0.004. So we are not able to reject the null hypothesis. Okay. Now we should remember the assumptions of t-test, that we have the independent sample from two normal population. Means the data which we are drawing from the population or about the what a particular characteristics we are measuring in a particular patient, that is going to follow a normal distribution. Okay, and we are interested in testing a hypothesis concerning the based on mean Third, population variance or standard deviations are not known, and we are going to approximate it from the sample, and the sample size are small. Okay. So if there are two population, then with this particular formula, we are going to combine the sample standard deviation. The test statistics which are used for testing two independent sample is this. You can see difference between two uh, independent sample. The mean of two independent sample are subtracted, and then it is divided by this formula. So the null hypothesis is that mean of group 1 is equal to mean of group 2 against the alternative that they are not equal. So for testing this, we are going to use this test statistics, and we reject if the test statistics is more than the tabulated value. Otherwise, we do not reject this. The formula of calculating the p-value is calculated by this particular formula. Now take this example to understand this. 22 volunteers at a cold research institute caught a cold after having been exposed to various cold viruses, and a random selection of 10 volunteers were given tablet containing 1 gram of vitamin C. These tablets were taken 4 times a day. The control group, consisting of other 12 volunteers, were given placebo tablets that looked and tasted exactly like the vitamin C. This was continued for each volunteer until a doctor who did not know whether the volunteer was receiving vitamin C or the placebo decided that the volunteer was no longer suffering from the cold. The length of the time the cold lasted was then recorded. So this is the data. The first 10 people are those. These are the group who are receiving vitamin C, and number of days are recorded for them. And this is the people who do not receive the vitamin C. Okay. Now, does this data prove that taking 4 gram of vitamin C daily reduces the time that a cold lasts? Okay. So, our alternative hypothesis is this one. You can see the alternative hypothesis is this one. He wants to prove that mu p is more than mu c, where mu c is the mean time a cold lasts when vitamin C. So vitamin C, when you are taking, your mean time is less, and mu p is the mean time when the placebo is taken. Okay, so mu p is something which is related to placebo, and mu c is which is related to vitamin C. This is the alternative hypothesis, because you want to prove that vitamin C, when you are taking, the mean time will be less, and the alternative hypothesis will be just reverse of it. So this is the first battle that you have to fight whenever you are testing a hypothesis. You should specifically mention what are your null and alternative hypothesis. If you are going to fail in stating your null and alternative hypothesis, then the interpretation is going to be wrong enough for you. So on the basis of the data, the X bar is 7.125 and Y bar is 6.450. Now the idea is, the null hypothesis is that this mu p is almost going to equal to or less than equal to mu c, and the standard deviation of one group and standard deviation, sample standard deviation in another group, and then they calculated the combined standard deviation using the formula which is described in the previous slide, and they calculated the test statistics. So this is the difference between X bar and Y bar here. And this is the formula for calculating the test statistics. And then they also use the tabulated value, that is 1.725. With this, we can say that the null hypothesis is rejected at 5% level of significance. Okay, so you can see that the null hypothesis is rejected. And what is the alternative hypothesis? Alternative hypothesis is that by taking vitamin C is going to reduce the time to get recovery. Similarly, if we have an example of paired sample t-test, the previous one which we were discussing are the independent sample t-test. Now, what actually happened in the paired sample t-test, that the case doesn't change. Okay, so it is, you can see the measurement of blood pressure before giving a drug at the baseline, and just after the giving a drug, what is the blood pressure level, and we want to compare the previous one and the later one. So now the data is paired. That is, you cannot say they are independent, they are dependent, because the case is the same. So if such case is there, so you can suppose that we are interested in learning about the effect of newly developed gasoline detergent additive on automobile mileage. So to gather information, 7 cars have been assembled and their gasoline mileage in units of million per gallon have been determined. For each car, this determination is made both when gasoline without the additive is used and when gasoline with the additive is used. So this is the car mileage. This is the car 1, 2, 3, 4, 5, 6, 7. Now the first data is mileage without the additive, and the second data is I think the first data is mileage with the additive, not without. And second data is mileage with without additive. Okay, cut paste में problem हो गया. So now what is the idea? It is easy to see that the two factor will determine a car's mileage per gallon. One factor is whether the gasoline includes the additive, and the second factor is the car itself. For this reason, we should not treat the two samples as being independent. Rather, we should consider paired data, because car is not changing. Okay, so in such cases, we are going to frame the null hypothesis mu x is equal to mu y, and the alternative hypothesis mu x is not equal to mu y, where the two sample consist the paired data xi yi. We cannot test this null hypothesis by looking at the differences between the data value in a pairing. So first of all, we just calculate the difference. Okay, this di, which is equal to xi minus yi, and if the null hypothesis is true, or if there is no impact of the intervention, so this xi and yi, they both are going to be same. Okay, so in such case, this mu d, which is the difference of mu x and mu y, so the null hypothesis now, this becomes 0. There is no difference. The difference between the previous one and the later one will be 0, against the alternative that this is not equal to 0. Okay, and for testing this, we have the test statistics given by this particular formula. You can see under root n by standard deviation, and this is mean d bar, means calculate the difference of all pair and take the mean of it. Okay, so this is rejected if this test statistics is more than this tabulated value. Otherwise, we fail to reject the null hypothesis, and the p value is calculated from the same formula. So with this, the difference is calculated by this. The mean difference is 0.7. Now we have to check whether this 0.7 is significantly different from 0 or not. And this comes out to be, test statistics comes out to be 1.917. and the tabulated value is 2.447. So the null hypothesis that the mean mileage is same whether or not gasoline use contain additive, it is not rejected at 5% level of significance, because you can see that the tabulated value is more than the calculated value. So it means it is falling into the acceptance region. So we fail to reject the null hypothesis. So consider if we are talking about the two P1 and P2. So consider two large population, and we want to test whether the proportion of these two groups are same or not. Respectively, the proportion of member of these two population have a certain characteristics of interest. Means the number of smoker in girls and boys are same, against the alternative that they are not same. So if you want to test such hypothesis, to test the null hypothesis, suppose the independent random sample of respective size n1 and n2 are drawn from these two population, n1 number of boys and n2 number of girls are drawn from such population, and x1 and x2 represent the number of elements. So this x1 by n1, it actually represents the p1, and x2 by n2 is actually represents the p2. So this you can say p1 is this, p2 is this, and combine p, it can be given by this. Means this is the population proportion of a smoker. And for this, the test statistics will be given by this particular formula. Again, you can see here they are just using the difference between the two proportion, and they're standardizing it with the combined standard deviation. And then they are saying that if test statistics is more than and equal to z alpha by 2, then you are going to reject the null hypothesis. The p-value is calculated by this formula. So this particular example is here. In a criminal proceeding, a convicted defendant is sometimes sent to the prison by presiding judge and is sometimes not. A question has arisen in the legal circle as to whether a judge's decision is affected by one, whether the defendant pleaded guilty or whether he or she pleaded innocent but was subsequently found guilty. So the following data refers to the individuals all having the previous prison record convicted on the second degree robbery. Okay, so 74 out of 142 who pleaded guilty went to prison, and 61 out of 72 who pleaded not guilty went to prison. So do this data indicate that the convicted individual chance of being sent to prison depends on whether she or he pleaded guilty? So just P1 and P2 is already being the probability that the convicted, or the proportion that the convicted probability who pleaded guilty will be sent to the prison. And similarly, P2 corresponding probability for one who pleaded innocent but was adjudged guilty. So this null hypothesis that both P1 and P2 are same, against the alternative they are not same. And just calculating this N1, okay, so 74, this is 52, and in another group it is 84. So from here also you can see that there is a significant difference between this P1 and P2, and you can also see that P value is almost very small, so the null hypothesis is rejected. Okay, for such a small P value the null hypothesis will be rejected. Okay. Here also, if the one-sided p-value is different, so the way of calculating the test statistics, instead of using the z alpha by 2, we have to use z alpha. So the example for this is also is being given. So I will skip this example. Okay. So I will stop here and ask if there is any question.
Thank you, sir, for such a knowledgeable and interactive session. Now, I would like to request to all participants that if there is any query regarding today's session, then please write your query in the chat box or raise your hand so I can send you the unmute request. I'm just waiting for your queries in the chat box. Or you can raise your hands so I can send you the unmute request. Thank you, Dr. Prashant. If there is any query, then you can simply write your query in the chat box or raise your hand. So you can talk directly to our respected resource person of the session. Thank you, Dr. Nakul, Dr. Prashant, Dr. Archana. Thank you very much for positive feedback.
So do I have to illustrate this with any software also, or just theoretical presentation, Amit?
Sir, it's up to you, sir. It's up to you, sir.
No, means if you people are, if anybody have illustrated something with any software, SPSS also.
Definitely, sir. Our two lectures at the end of the month is for practical session using SPSS delivered by Dr. Dharmendra Yadav, sir.
Okay.
I think our participants get answer to their queries. So we are not receiving any queries. Thank you very much. I'm just writing one mail ID in the chat box. If there is any query remaining regarding today's session, then please send us mentioning us in the subject line the session or topic or guest speaker name, so I can forward that query to our respected guest speaker of the session. Now, I would like to introduce today's chairperson of the session, respected Dr. Atul Juneja, sir. Sir is former scientist F and coordinator clinical trials registry India CTRI ICMR New Delhi. And sir is currently working as a guest faculty at AU Tibia College, Government of NCT Delhi for research methodology, and also working as a visiting consultant biostatic at PSRI Hospital New Delhi and a visiting faculty at Nehru Homeopathic College and Hospital New Delhi. Sir is presently member of various scientific committees like member of National Advisory Board of Journal of Case Reports published by All India Institute of Ayurveda, member of Scientific Advisory Committee, Clinical Research and DSMB of Central Council for Research in Ayurvedic Sciences, CCRS, New Delhi. Member of TNP Committee of Jaipur Golden Hospital, PSRI Hospital, Mamta Charan Devi Hospital, New Delhi, and National Heart Institute, New Delhi. Dr. Atul Juneja sir authored the course material for the MBS program of International Institute of Population Studies. In past, sir nominated as representative of ICMR for expert committee member of Central Pollution Control Board to provide the technical opinion to Honorable National Green Tribunal on remediation of mercury as a result of mercury pollution in soil near thermometer factory Kodai Canal. The recommendations were accepted by Honorable Court. Sir had been a member of selection committee of various projects course at National Institute of Medical Statistics. Sir had been visiting faculty to Guru Gobind Singh IP University, New Delhi for teaching research ethics for PhD programs. Presently, faculty of DNB program of Ops and Gynae for research methodology and biostatics. Sir delivered more than 60 lectures or served as a panelist for the various Central Statistical Organization, RML Hospital, PGI Chandigarh, Government Medical College Chandigarh, Rajasthan University of Health Sciences, Jaipur University, MD University Rohtak, CCRS, CCRH, and Jamia Hamdard University New Delhi during last 10 years. Sir is also a member of various professional associations like member of National Academy of Medical Sciences, life member of Indian Society for Medical Statistics, life member of Indian Society for Information Theory and Application, life member of Indian Association for Population Sciences, had been annual member of Indian Association of Center Research. Sir has published more than 60 publications to credit with the 25 as first author. Sir has attended more than 70 national and international reference conferences, including invited talks. International participation include countries like USA, Canada, Singapore, China, and Malaysia. Now, without taking too much time, I would like to request sir to kindly share some views and his experience regarding today's session with our participants. Please, sir,
Uh,
welcome, sir.
Thank you, Mr. Tiwari. It was really humble to with your kind words. Let me express my gratefulness to you for letting me the chair this session. I must be very honest in saying that it was such a very great and wonderful session. If I may say, it was just like sitting in a cozy environment in a drawing room in a comfortable place and listening to, not listening to a lecture, but uh, such a difficult, I won't say difficult, but obviously it's a very technical topic which has been presented with such a simple and day-to-day examples which could reach out to everyone, I think. So it was such a very treat to hear, Dr. Anup. Thank you so much. Really, I enjoyed, not as a chair, but as a participant, it was wonderful hearing you. Thank you so much and look forward to more from you. Thanks.
Thank you so much, sir, for your kind words and for your feedback regarding the session. Now, on the behalf of Institute of Applied Statistics and the National Institute of Ayurveda, we convey our sincere thanks to all the participants for their active participation and commitment for today's session. We heartily thank the guest speaker of the session, Dr. Anup sir, who kept the participant engaged by a very informative lecture. We also thank Dr. Atul Juneja sir for chairing today's session and sharing his experience and views about the session with the participants. Now, this is the end of today's session. We again thank all of you. Tomorrow,
Thank you.
we
Bye.
have one session on computation and application of correlation and will be delivered by Dr. Atanu Bhattacharya sir. So please join at 6 p.m. at the same time. And this is the end of today's session. And thank you again. Thank you very much, sir.
Thank you.